In 5.3, we're shifting to a new rule now in probability called the multiplication rule. And for the multiplication rule, we have a keyword called AND. So here in the handout, this is the formula for the probability A and B. So whenever the word AND is associated, here we can multiply the probability of A times the individual probability of B, only if A and B are independent. So here's the thing. The word AND only has one formula, as opposed to the keyword OR, which had two formulas. So this keyword AND, okay, we can use this formula here only if A and B are independent. So what does independence mean? That means that if two events are independent, then when one event occurs, it does not affect the probability of the other event. Okay, so let me give you some examples before we look at example 1 on what independence means. Okay, so the question here is, do we have independence? Okay, so suppose event A is equal to a first coin toss is heads, and event B, a fair die, is 2, for example. Okay, so the first event occurs, right? The first coin toss is a heads. The question is, does that event, just by occurring, change the probability of event B? The answer is no. Okay, so what we say A and B, they're independent. Okay, one event occurring doesn't affect the probability of the other. But then think about these two events here. Let's say C is the event study for test, and event D is pass the test. Okay, the question is, are these two events independent? And the answer is no, because one event occurring does change the probability of the other occurring. So if we study for the test, our chances or our probability of passing the test increases. If we don't study for the test, then the probability of passing the test decreases. Notice how it's changing the probability for the other event. These two events are called dependent. Okay, so that's what independence means. So whenever we're looking at example 1, we want to ask ourselves, if we see the keyword AND, can we use this multiplication rule? Okay, so let's take a look. So in example 1, 13% of the population is left-handed. If two people are randomly selected, what is the probability that both are left-handed? Okay, so here we're looking for the probability that we have both individuals are left-handed, and we're looking for a keyword. Okay, that keyword is AND, but we don't see it, right? So we need to look at the phrasing here, both individuals being left-handed. What does that mean? Well, if both individuals are left-handed, that means that we have that the first individual is left-handed and the second individual is left-handed. Okay? Call this event A, call this event B, then what we have is the probability of A and B. So we have a formula once again for the word AND, but we can only use it if A and B are independent. So consider that we have a population and two people were randomly selected. Okay? So if two people were randomly selected, one person being left-handed has nothing to do with another person being left-handed. So both individuals are independent. Okay? They're independent. Since they're independent, then we can proceed with the formula. So the probability of A and B is equal to the individual probability multiplied this time. Multiplied. Okay? So what is the probability that person A is left-handed? Well, 13% of the population is left-handed. So we have 0.13, okay? What is the probability that person B is left-handed? Okay, likewise, here we have 0.13, okay? So when we multiply these two probabilities together, that's going to give us the probability 0.016